How are you doing? Thank you once again for joining me for another math lesson with Mr. Woodford. Today we're going to begin to work on looking at Unit 2, the number system with Math 8, and we're going to look at lesson 1.6, rational and irrational numbers. Now this is one of the lessons that's going to be a key lesson in order for us to understand different numbers on the number line, between fractions, decimals, radicals, right? Of course, integers and whole numbers, but it's important for us to really take a second to really dive into this lesson. So if you have your packet with you, please open up to lesson 1.6. If you join us in Google Classroom, make sure you open up to the actual lesson, and let's begin. Now, as we normally do with every single lesson, you're given something called the bell work, which is the beginning of our lesson and which we are to do as we start. What I want you to do is finish the list of 10 perfect squares that I've started for you. The first and the fifth are done for you. And to try to explain, let me explain how A and E are done. I'm thinking about the number 1 times 1 gives you 1. That means 1 is a perfect square. The second one, to start us off, we'll start with the very second number, which would be something like this. 2 times 2 gives us 4, which means that 4 is a perfect square. And you can probably get the pattern from there on. So please pause the video now and complete the rest of this spell work. Awesome. I'm hoping that as you paused, you was realizing, wow, these numbers, they're not that bad. You've probably even seen some of these numbers before, right? 3 times 3 gives us 9, right? And matter of fact, let me just write it fully out. 4 times 4 gives us 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. And 10 times 10, of course, is 100. You see all of these numbers, 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. These are known as perfect squares because they were made by multiplying one number by itself, right? And there's an inverse to a square. It's called the square root. So these are perfect squares, and we're going to look at these a little bit more later. But let's dive in and let's look into what we're talking about today and how to differentiate and how to figure out between rational and irrational numbers. This is going to be a really, really good lesson, and I'm excited to share with you. So before I even begin, of course, we can scroll down. We're going to look at this visualizing vocabulary chart. And in addition to that, I want you guys all to make sure you do have your calculator with you. Okay. Now, as I was saying in class, I would prefer you guys get a TI-30 XIIS. This is only Math 7 and 8 I'm going over right now. So Math 8, you only need this calculator. You don't need the actual TI-84, which does a lot more computations. For now, let's dive into looking at the vocabulary. We have real numbers. Right? We have a category of numbers. There are real numbers and there's not real numbers. For the purpose of all of 8th grade, we're only going to be dealing with the real numbers. So don't worry about not knowing the fake numbers. And then in the real numbers, there's 2 categories, rational and irrational. So underneath the umbrella of real numbers, there's rational numbers and then there's irrational numbers. Let's go over what irrational numbers are. So rational numbers are like 2/3, 3/4, 1/8. -2, 1, 2, 3, 1, 2, 3. All of these numbers, even these whole numbers, even the natural numbers, even the integers, are all considered rational numbers. That's why they're all in this big old bubble. All of this is rational numbers. Okay, and I'm going to tell you exactly how do we discern between irrational and irrational in a second. But let's go through the rest of them. An integer is like -5, +9, -2. The square root of 49. How come the square root of 49 is there? Because remember, the square root of 49 becomes the number 7. It's one of those perfect squares inside of a square root, which we'll also talk about that in a little while as well. 0. These are integers. Whole numbers. 0, 1, 2, 3. These are all considered whole numbers. And notice there's no negatives there as the integers. The integers had negative numbers. Whole numbers do not have negatives. But are whole numbers rational? Yes. Are integers rational? Yes. Natural numbers are numbers starting with 1, 2, 3, 4, 5, 6, 7, and on. Okay, so these are the categories and the breakdown of rational numbers. Okay, whereas irrational, you may have seen pi before. That's an irrational number. Radical 10, square root of 2, square root of 3, or radical 3. Notice how I'm saying it? It can be said either way. Some people say radical 3, some people say square root of 3. All right, and of course 1, 2, 3, 4, 3, 4, 8, 7, 1, and you can see it has no particular pattern, and it goes on and on and on, which is indicated by those 3 dots. Let's look at this table here. The number radical 2 is an irrational number. Now, why is that the case? Because 2 is not a perfect square. We look up on our chart, we can see the number 2 is not one of these numbers that are equaled, right? 2 times 2 gives you 4, but 2 itself is not a perfect square. 4 is, okay? It's irrational, radical 2. But the square root of 9, or radical 9, that is considered rational. Why? Because 9 is a perfect square. And as you can see from this example here, the square root of 9 is 3. The square root of 9 is 3. And then they give you 2 different decimals, which I want to do them with you and show you what they are. Because I think this is where it's important for us to get a hang of understanding rational, irrational. You may be thinking to yourself, well, how do I know if it's rational or irrational? I haven't even mastered the perfect squares yet, Mr. Winford. No problem. I'm going to tell you the very basic definition of a rational number. Now, this rational number you see here, right, 0.0101010101, you can see it's repeating decimal, and there's a pattern to it, okay? Now, can you get in the habit of you looking at that and say, okay, because it's a repeating decimal, because it's a pattern, it's rational? You could. But I'm going to teach you a way to do it that will be bulletproof today and allow you to be able to understand if it's rational or irrational every single time. And we're going to use our calculator. What I want to do is put that number in my calculator. I'm going to put that in as 0.010101010101. And then what I'm going to do is I'm going to click on the second button, PRB, and I want to turn this into a fraction. So once again, how do we turn a decimal into a fraction on our calculator? We are going to click on the second button, and I'm drawing buttons here. It's a button, second, and the other button is PRB. Okay, this, after you type in your decimal, you hit second PRB, enter. Let's put the enter button there as well. And then you'll see your decimal come. Your decimal turn into a fraction. Now this one turns into a fraction of 1 over 99. 1 over 99. Okay, Mr. Winford, I get it. I can turn a decimal into a fraction, but there's much more than just that. If the decimal can turn into a fraction, that's an indication that this number is rational because it can be written as a ratio. For example, if we look at the second one down here, we tried to turn this one into a decimal, into a fraction. If we try to turn 0.01001000010001 and it keeps going into a fraction, it's not going to turn into a fraction. One, because there's no pattern and it's not the same repeating pattern, right? So I want you to understand something here. The quickest way to identify something as rational or irrational is seeing if it turns into a fraction. Let me model 2 examples for you today to be able to show you. But our goal is to be able to take a decimal, put it into the calculator, and see if it turns into a fraction. The way we're going to do that is once you type in your decimal in your calculator, you're going to hit second PRB, enter. And that should pop out a fraction for you. If it pops out the same decimal, and please listen to me, if it gives you the same decimal, then no, it is not rational. It is irrational. If I try to turn pi into a fraction, it's not going to give me a fraction. It's going to give me the same number pi. And that's what identifies something as rational or irrational. If it can turn into a fraction, it's rational. Let's look at the modeling. So I'm given radical 77 or square root 77. My goal is to tell if this is rational or irrational. I've broken this down into 4 different steps, and the way I want you to do is first, I want you to tell me what is the decimal value of radical 77. Now, for some of you guys, like, I have no idea how to put this square root house thing in the calculator. No problem. Once again, I'm going to walk you through the steps. Click on the second button. Click on the second button. Then you're going to click on the X squared button. It looks something like this. That's the x squared button. All right. Once you click on second x squared, you'll see the little house thing pop up for you. Then put the number 77 in. Hit enter, and you'll get a decimal value like this, 0.8774964387. Now notice this. I'm writing the whole decimal out. Why is that? Because if I stop short at any number here and I don't write the rest of this decimal, it could very well turn into a rational number. Because if you only put the full decimal value and you try to turn it into a fraction, it may turn into a fraction, but that's not the same number that you're trying to compare. So please make sure when you're finding out the decimal value of numbers, write as many digits as you possibly can. Write as many digits until the calculator stops, right? And that's going to allow you to have the best and most accurate description of whether or not it's rational or irrational. Now, the next thing I want you to do is say, okay, can this turn into a fraction? We check to see if it turns to a fraction by simply doing second PRB, enter. Second PRB, enter, right? When we click on that, right, let's see if this turns into a fraction. And what you'll notice is it gives us the same decimal as above. What does that mean, Mr. Rivera? I didn't type the buttons in right? No, you did type the buttons in right, because I too got the same decimal. So what does that mean in terms of rational or irrational? That means this number, this radical 77, is irrational. It's irrational, okay? Now, we want to make sure we're practicing and put them in right. We're hitting second XR squared, putting it in, seeing what the decimal is, and trying to turn that decimal into a fraction. If it goes into a fraction, it's rational. If it does not go into a fraction, it's irrational, okay? Why? Because, and that's a B, right? It can't turn into a fraction. And now I'm also going to put this terminology here to prepare you as you get older into the future, ratio, okay? It can't turn into a fraction or a ratio, okay? This is the definition of understanding if something's rational or irrational, okay? All right, so that's it for now. I'm not going to do B. Please let me know if you have any questions. You can always reach out to me. I'll do my best to try to help you. But thank you so much for joining me. Looking forward to seeing your amazing work. And if you have any questions, always reach out to me. Have a great day. Bye-bye.